Hello students, welcome to Smart Study Guide by Ajay sir. This is new syllabus HSC Maharashtra State Board Standard 12 Science Subject Physics Lesson number 9 Current Electricity. Today we are solving exercise numericals based on current electricity. This is part 2. Already we cover question number 10 to question number 14 in part 1. So this is part 2. In this part we are discussing question number 15 to question number 20 exercise numericals based on current electricity. So let us start question number 15. So when two cells of EMF E1 and E2 connected in series so as to assist each other, their balancing length on potentiometer is found to be 2.7 meter. When cells are connected in series so as to oppose each other, the balancing length is found to be 0.3 meter. Compare the EMF of cell. So here this example is based on potentiometer. So in potentiometer apparatus, so there are two cells are connected of EMF E1 and E2. So first they connected in series, means so they assist each other, means positive terminal, negative terminal of one cell. The negative terminal of one cell is connected to positive terminal. So this combination is called as assist. So in this combination, so balancing length is 2.7 meter. And when cells are in series, are connected in series so as to oppose each other. Cells are connected and they oppose each other. Means when suppose positive and negative terminal of one battery and another battery again positive and negative terminal, when negative terminals of two batteries are connected, so then they oppose each other, and then in that case balancing length is 0.3 meter. So this is the condition given. These are the balancing length when cells are in assist. Assist means E1 plus E2. So in that case balancing length is 2.7, and when cells are in oppose, then EMF is E1 minus E2. In that case balancing length is 0.3 meter. Compare the EMF of two cells. Means you have to find E1 divided by E2. So let us write the given things. Given the first balancing length, that is L1, which is equal to 2.7 meter, and second balancing length, that is L2, it is 3.3 meter. So these are the given information, and we have to find the ratio, that is E1 divided by E2. So this we have to find. So therefore we know that the formula, by using formula, when cells are connected to the potentiometer, formula is E1 divided by E2 is equal to L1 plus L2 divided by L1 minus L2. So this is the formula. So here we can consider epsilon or E also. Instead of epsilon we can consider E also. So E means EMF. So we can represent by symbolically by epsilon. So this is the symbol for EMF, or we can simply say that E1 and E2. Therefore let us put the given values. L1, that is 2.7, plus L2, that is 0.3, divided by L1 2.7 minus L2 0.3. So therefore numerator 2.7 plus 0.3, that is 3, divided by 2.7 minus 0.3, that is 2.4. Let us multiply numerator and denominator by 10. So the numerator becomes 30 and denominator becomes 24. By using table of 6 fours are 24 and 6 fives are 50. So therefore this is 5 by 4. So let us divide this. 4 1 1. So 4 1 1 and 1 is remaining. Then 4 twos are 8. Again 2 is remaining and 4 fives are 20. So means 1.25. So this is the answer, that is E1 divided by E2. So this is the ratio, or this is the comparison of two EMFs. So therefore the ratio of EMFs of two cells is 1.25. So this is the answer. So now let us start question number 16. The EMF of cells is balanced by the length of 120 centimeter of potentiometer wire. When cells is shunted by the resistance of 10 ohm, the balancing length is reduced by 20 centimeter. Find the internal resistance of cell. Now this example is based on one of the application or use of potentiometer, that is to find internal resistance of cell. So now here cell is connected to a potentiometer of length 120 centimeter. So let us write first given things. So therefore the length of potentiometer wire, so that is 120 centimeter. So that is EMF. When EMF of cell is balanced, so that time length is 120 centimeter. So therefore the first balancing length is given. So that is given thing, that is L1, that is balancing length. When two cells are balanced, so then L1 which is equal to 120 centimeter. When cells is shunted, means that cell is connected to the parallel resistance of ohm, that resistance of ohm 10 ohm. Therefore resistance that connected to the cell, that is 10 ohm, and the balancing length is reduced by 20. So then another length you will get, that balancing length when that resistor is connected in parallel with the EMF of the cell. So therefore the length which is reduced by 20 means original length of balancing length, that is 120 centimeter minus 20. So therefore this is 100 centimeter. So this is the second term. So that is second part. So then balancing length becomes 100 centimeter. So this is the given thing, and you have to find the internal resistance of cell. So therefore internal resistance, that is small r, and external resistance that parallel with the cell, that is capital R. So by using formula of internal resistance of cell, therefore by using internal resistance of cell formula, so therefore small r which is equal to capital R into bracket L1 divided by L2 minus 1. So let us put the given values. R which is 10, L1 that is 120, L2 that is 100 minus 1. So let us solve this. So therefore this is inside, this 0 and this 0 will get cancelled. So therefore inside So this is 10 which is outside, which is multiplied by 12 divided by 10 minus 1. So let us use table of 2. 2 6 are 12 and 2 5s are 10. So therefore 10 into 6 by 5 minus 1. So therefore let us cross multiply this inside. So 10 into, so here numerator there is a 1 and denominator nothing is there, means 1 is always there. Is 6 minus this 5 will multiply here, 6 minus 5 divided 5 into 1. So 1 denominator is numerator, denominator is again 1 here. So therefore 5 into 5 5. So this is cross multiplication. So therefore 10 which is outside only. So 6 minus 5, that is 1 divided by 5, and this 5 and this is 10. So therefore 10 divided by 5. So therefore answer is 5 2s are 10, that is 2. So therefore R which is equal to 2 ohm. So this is the answer. So therefore internal resistance of cell is 2 ohm. So this is the answer of question number 16. Similarly, let us solve question number 17. So a potential drop per unit length along a wire is 5 into 10 raised to minus 3 volt per meter. Potential drop is given, and if the EMF of cell balances against the length, that is 216 centimeter of this potentiometer wire, find the EMF of cell. So here the EMF of the cell when it's balanced, so that balancing length is given, that is 216. So this balancing length is given here. So therefore, and potential drop is also given. So potential drop means potential per unit length. So it's called as potential drop, okay, or potential per unit length, that is K is given, and the balancing length, that is 216, and we have to find what is the EMF of the cell. So let us write the given things. So given potential drop per unit length, potential drop per unit length, that is K is given. So this K, value of K, that is 5 into 10 raised to minus 3 volt per meter. This is given. Then balancing length, small l, 216 centimeter. So therefore let us convert this 216 centimeter. So this is in CGS unit. So let us convert this into meter, that is 216 10 raised to minus 2 meter. Therefore this is 2.16 meter. So this is small length L. So this is L, balancing length. So here, now next, that is to find the EMF of cell. So what is the EMF of cell? So this you have to find. So let us use the formula. By using formula, that is E is equal to K into L. So this is the formula, that is the principle of potentiometer, that is EMF of the cell is directly proportional to the length of the wire, and K is a proportionality constant, that is called as potential drop per unit length. So therefore let us put the given things. So therefore here E which is equal to K, K means 5 into 10 raised to minus 3 into L, that is 2.16. So let us multiply this. So after multiplication of these two numbers, so let us cross multiply 2.6 into 5. 6 5 is are 33. So then 5 1 1. So 5 into 1 5 plus 3 8. Okay. So now 5 into 2 10. So 10.18 into 10 raised to minus 3. So this is the EMF in volt. For EMF E, which is equal to 10.80 into 10 raised to minus 3 volt. Or you can simplify again. So dividing by 1000. So then this side is 0.0108 the volt. So this is the answer, or this is the EMF of the cell. Similarly, let us solve question number 18. The resistance of potentiometer wire is 8 ohm and its length is 8 meter. The resistance box and 2 volt battery are connected in series with it. What should be the resistance in the box if it is desired to have a potential drop of 1 microvolt per millimeter? So in this case, again potentiometer wire of length 8 meter is given and the resistance of that wire, that is 8 ohm. So first write the given things. The resistance of the wire, that is 8 ohm. The length of the wire, that is capital L, that is 8 meter. The resistance box and the 2 ohm battery are connected in series. So this resistance box and the battery are connected in series with it. Then what should be resistance in the resistance box if it is desired to have the potential drop of 1 microvolt per millimeter? So potential drop, then what should be the resistance in that resistance box when it is connected to the battery? So resistance box is connected to a battery in series. So battery of EMF, that is 2 volt, and it is connected with the resistance box. Then what should be the resistance of resistance box? That is external resistance we have to find. And one more thing is given, that is potential drop, value of potential drop. So potential drop per unit length, that is K, which is equal to 1 microvolt per millimeter. So 1 microvolt means 1 into 10 raised to minus 6 volt per millimeter means 10 raised to minus 3 meter. So therefore this 3 will go up. So then minus 3 become plus 3. So therefore 1 into 10 raised to minus 6 plus 3 volt per meter. So therefore this is only 10 raised to minus plus minus, that is minus 3 volt per meter. So this is the value of K, potential drop. And so here we want external resistance. So what is the value of external resistance? So that is R of E. So let us use the formula. By using formula, that is K is equal to V by L. So this is the formula, K which is equal to V by L, or we can write V which is equal to IR, that is I into R divided by L. So instead of R, so instead of I we can use, so I, since I which is equal to capital E, so that is EMF, and total resistance, that is external resistance, so that is R, that is resistance box, so that is resistance of the wire plus external resistance box. So this is the total resistance. So therefore K, which is equal to I into R, therefore R divided by L will be constant into E divided by small capital R plus RE. So let us put the values, or first we will rearrange the term because we want RE. So therefore we will first rearrange the term in the form of RE and then we will put the values. Now here this full term we will shift to the left hand side and this K we will shift to the right hand side. So therefore this will be R plus RE, which is equal to RE divided by L into K. So therefore we want only this resistance, that is external resistance. So therefore RE, which is equal to, and then this resistance of the wire, that term we will shift to the right hand side. So therefore this will be RE divided by L into K minus R. So let us put down values. Capital R, which is equal to 8 into EMF, that is 2, L, which is equal to 8, and K, which is equal to 10 raised to minus 3 minus R, which is equal to 8 again. So now this 8 and this 8 will get cancelled. So therefore this is 2 divided by 10 raised to minus 3 minus 8. So therefore we can write this, that is, so this 10 raised to minus 3 will go in the numerator. So therefore this is 10 into 10 raised to 3 minus 8. So therefore this is 2 into 10 raised to 3 means 1000 minus 8. This we will write in one bracket. So therefore, so this term we can write here. Therefore, so this 2 into 1000, that is 2000 minus 8. So 2000 minus 8, that is 1992. 1992. So this is the answer. This is the external resistance, 1992 ohm. So this is the answer. Similarly, let us solve the next question, question number 19. Find the equivalent resistance between terminals of F and B in the network shown in the figure below, given that the resistance of each resistor is 10 ohm. So this is the circuit diagram is shown, and this is terminals F and B, and what is the current. So find the equivalent resistance. Find the equivalent resistance between this terminal as shown in the figure. So this we have to find. If we have to find this internal or equivalent resistance of these terminals, so these are the resistors, they are connected here, and each resistors of resistance, that is 10 ohm. Each resistor resistance value is also given, that is 10 ohm. And this is the battery connected, and its battery value, let us consider the EMF of the battery will be 10 ohm. So this battery is connected. So this is the current flowing through the battery, that is I is the current flowing through from positive terminal, and this current will ends on another terminal, that is negative terminal. So this is the direction of current. So at this point F, the current which is divided into two parts. Suppose here in this arm, so current which is flowing, that is I1, total current is I. So therefore I minus remaining current, I minus I1, so that will flow in this arm. The same current will flow in this part also. Now same current will come at this point, at G point. So that current, that is I1. Now again this current which is divided into two parts. Suppose this part current flowing, that is I2 in this part or in this arm, the current which is I2. So therefore the remaining current, that is I1 minus I2, so it will flow in this arm. So therefore this is the current I2, so that passing through this terminal, so this arm, and again it will come back to the point B. So at this point B, the current will come back, that is I2. So therefore same current now here I2, and in this arm, that is I1 minus I2. So therefore I1 minus I2 in this point. So therefore at this point, H point, so from this arm the current which is flowing, that is I minus I1, and here I1. So minus I1 get cancelled if you add here. So then therefore remaining current, that is I minus I2 current will come or flowing through this arm. The remaining current, that is I minus I2, after combining this. So this and this current when combined, I1 term will get cancelled because this is plus I1 and this is minus I1 get cancelled, and remaining, that is I minus I2. So that is I minus I2 is current flowing through this arm. So therefore this is at this point again same current will reach I minus I2, and this is I2, so this current will get add here. So therefore this is minus I2 and this is plus I2. After adding, it will get only I1. Therefore I1 current again come back to this point. So therefore I current will flow again in this arm. Means current flowing, that is I1, again come back the same current, that is I. So this is the circuit given, and so therefore we have to find what is the equivalent resistance between the terminals F and B. Between this terminal, so what will be the equivalent resistance? So to find the equivalent resistance, we have to consider different loops, and we have to apply Kirchhoff voltage law to these loops, and then simultaneous equations you have to solve. So let us consider this loop. So let us consider this is the first loop. Let us consider this is the first loop, and current flowing in this loop, direction of current, that is this. Direction of current is this. So let us consider the current which is flowing in this circuit. So let us consider this is the current. So therefore to show this, so same current will flow here in this arm. This is the direction of current here. So now let us find out what is the, so let us apply first Kirchhoff voltage law to this loop. First we will consider let E be 10 volt. So this is not given, so this we will consider, let E be 10 volt. Let us consider the loop H, J, F, G. Let us consider this is the first loop, and the direction of tracing will be this direction, that is clockwise direction. Suppose this is the direction of tracing the loop, that is H, J, F, G. So apply Kirchhoff law to this loop. Therefore applying Kirchhoff voltage law in loop 1. Suppose this is the direction of tracing H, J, F, G. So this is the direction of tracing and the direction of conventional current, and let us apply. So here in this arm, suppose we are starting from H point and we come back again J point. So when we come to the J point, so direction of tracing and direction of conventional current are opposite. So therefore EMF here, which is positive because direction of tracing and direction of conventional current are opposite. Now same current is here, so same current will come from this arm and same current will come to this point also. So therefore resistance here, that is 10 ohm and 10 ohm, it will get added because they are connected in series. So therefore total resistance in this arm, that is 20. So the resistance is equal to 20, but current is same, that is I minus I1. So therefore potential here V, which is equal to IR. So therefore I into R. So this is a potential, it is I minus I1. So this is a potential here, I minus I1. But direction of tracing and direction of conventional current are opposite. Direction of tracing and direction of conventional current are opposite. So therefore this is positive. So therefore EMF is positive in this case. Now let us start from this point to G point. The direction of conventional current is and direction of tracing is same. So therefore potential is negative, that is 10 into current, that is I1. As we are at this point. Now from G to H, the current which is I minus I1, direction of tracing and direction of conventional current are same. So therefore potential drop, this is minus I1 I2 into 10, so which is equal to 0. So therefore let us multiply this 20 inside. 20 I minus 20 I1 minus 10 I1 minus this minus, then this is 10, we are multiplying, this is 10 into I1. Again this 10, this is minus, then this minus will remove. So therefore minus minus become plus 10 I2. This is equal to 0. Now all like terms we will add or subtract and remaining terms we will keep as it is. Now here only I term is one time, so therefore it is only 20 I. So then next term all I1 terms, so here minus 20 I1 minus 10 I1 and minus 10 I1, minus minus become plus, therefore this is negative, minus 20 minus 10 and minus 10 again, so this will therefore minus 20 plus 10 plus 10, it is 40 I1. Sign for the greater, that is minus 40. Last term, that is 10 I2. This is the final expressions you will get. So therefore again we can simplify this further. So dividing 10 both the sides. So let us dividing 10 each term. So then this term becomes 10 into I minus 4 into I1 plus I2, dividing 10 throughout. So therefore, so only this term if you shift to the right hand side, so then this will be only 4 into I1. So then this will be 2 into I plus I2. This full term we will shift right hand side, 4 into I1. So further also we can divide this. Therefore let us convert this equation in the form of I. So therefore 2 into I we will keep in the left hand side only, and 4 I1 minus I2. This I2 we will shift to the right hand side. So now this I, which is equal to dividing 2 to the right hand side, 4 into I1 minus I2 divided by 2. So let us call this is equation number 2. Now similarly, applying Kirchhoff voltage law in the loop 2. So let us consider now, because here 3 loops are there, first, then this is second and third loop. Let us consider this is third loop. Again this is second loop. Now again the direction of tracing is similar. So this is the direction of tracing. Let us apply Kirchhoff law, voltage law in the loop 2. Kirchhoff voltage law in loop 2. So again direction of tracing we can consider. Suppose here the direction of, so here in this case I2 current which is flowing, so this is the resistance, same current which is flowing, so therefore this resistance get add total resistance which is this 10 ohm plus 10 ohm, that is 20 ohm, and current which is I2. Suppose current direction of tracing is this from G point, G, A, B, F and G. Suppose therefore the direction of tracing and direction of conventional current are same, so therefore the voltage, potential drop, that is voltage between these points G and B, so that is negative. So therefore this is minus 20 into I2. So this is the potential drop. This is the potential. So therefore now we will come to the point B. Again direction of tracing and direction of conventional current now here opposite. So therefore here they are opposite. So therefore this is potential or EMF. EMF in this case, that is positive. Therefore current is here, that is I minus I2. So this is I minus I2 into 10. So now they are opposite, so that's why here it is positive. Conventional current and direction of tracing are opposite. Now we are at this point, direction of tracing is this, direction of conventional current is opposite. So therefore again here it is positive, EMF which is positive. So in this case again it is I minus, that is I1 minus I2 into 10 which is equal to 0. Let us simplify this. So therefore minus 20 into I2 plus 10 into I minus 10 into I2, again multiply this 10 inside, plus 10 into I1 minus this is I2 into 10 which is equal to 0. So therefore we can directly writing this without writing this cross sign. This is minus 20 I2 plus 10 I minus 10 I2 plus 10 I1 minus 10 I2 which is equal to 0. Let us combine the like terms. So therefore this is 10 into I. So this I2 and this I2 and this I2 will get add. So therefore all are negative. So minus, minus, minus. So therefore minus minus get adding and you will get only minus 20 plus minus 10 minus 10 is 20 plus 10 plus 10, that is 40 I2 minus 40 I2. And I1 term, only one term is there, that is plus 10 I1. So which is equal to 0. So therefore let us shift this term, full term, to the right hand side. So therefore this term will be, so 10 into I plus this 10, that is 10 I1. This full term we will shift to the right hand side, that is 40 I2. So dividing throughout by 10. So then this is I plus I1 which is equal to 4I2. So let us call this is equation number 2, students. So let us call this is equation number, or this equation, let us call this is equation number 1. This is equation number 1. This is equation number 2. And this is equation number 3. So now substituting equation 2 in equation 3. So we can substitute here I1. So therefore after substituting, or we can write this in the next page. Substituting, just we have to substitute instead of I1. So we have to put the value of I1, or substituting equation 2 in equation 1 directly. So then you will get only, so right hand side, that is 4 into I2, and left hand side, instead of this I1, instead of this I, so we can use 4 into, or we can use this I1 and substituting equation 2 in equation 3. Equation 2 in equation 3 we get in question number. So therefore question in equation 3, so equation 3, that is 4I2 which is equal to I plus I1. So I which is equal to, that is equation from equation 2, I which is equal to 4I1 minus I2 divided by 2 plus I1. So this is equation number 3, that is 4I1 which is equal to I1 plus, so this is I plus I1. So therefore this is the value of I from equation 2. So let us simplify this. So let us both the sides multiply by 2. So multiplying 2 both the sides, we get, so this side, right, left hand side, so if you multiply by 2, this become 8 into I2 which is equal to, so this 2 and that 2 get cancelled, 4I1 minus I2 plus this right hand side, that is twice I1. So multiplying by 2 you will get twice I1. So now I2 term, let us combine I2 term. So then this minus term we will shift to the right hand side. So this is already in right hand side. Let us shift this minus term in the left hand side. This is 8 into I2 plus I2. This is 4I1 plus 2I1. Therefore this is 9I2 which is equal to 6I1. So therefore this is this term, full term we shift to the, so this 6 we are dividing by, so this is 9 divided by 6 I2 which is equal to I1. 3 2s are 6 and 3 3s are 9. So therefore this is 3 by 2 into I2 which is equal to I1. So therefore I1 which is equal to 3 by 2 into I2. So let us call this is equation number 4. Now applying Kirchhoff voltage law to the third loop. So this is our first loop, this is our second loop, and let us consider the third loop is this. So direction of tracing is again clockwise. Now, so this is the direction of current. So now this is the direction of tracing also. So there is a. So now let us apply Kirchhoff voltage law to the third loop. So therefore, applying Kirchhoff voltage law in the loop 3. So let us consider this is the direction of current. Now this is the EMF. So let us consider this point E. So we are starting from this point. The direction of tracing is this direction. Direction of current is again same. So here in this case, I minus I1 current direction and direction of tracing are same. So same current will flow here. So therefore this is the direction of tracing. Same current will come to this point. So but resistance are adding. So therefore 20 ohm is the resistance. So therefore potential drop. So therefore potential, that is V, which is equal to IR, R which is equal to 20, and current which is equal to I minus I1. So direction of tracing and direction of current are same. So therefore this is negative. Potential is negative. Same current. Now in this case the current is I minus I2. It will flow to this arm. Direction of tracing is same. So therefore again here minus 10 into I minus I2. Now same current will come to this point. Now here in this case current is I. So when we will traverse from negative terminal to the positive, EMF is second terminal, that is positive, into E. Positive E. So that is 10. So therefore this is equal to 0. Again same current will come back to this point E. So now let us multiply this inside. So therefore EMF we consider that is 10 volt. So let us consider this is EMF. We will keep this EMF in one side and all this term we will shift to the right hand side. So therefore E we will keep left hand side and all these negative terms we will shift to the right hand side. Then this becomes 20, so minus become plus 20, I minus I1 and plus 10 into I minus I2. So let us multiply this 20 inside. So E value, that is 10, EMF we consider that is 10. So then 20 inside, that is 20 into I. So 20 into minus 20 into I1 plus 10 into I. So then minus 10 into I2. So now I term. So this is I term and this is I term. So both terms will get added. So then this becomes 30 into I and minus 20 into I1 minus 10 into I2. Dividing both the sides by 10, we get, this is 1, 10 divided by 10, that is 1. Then after dividing by 10, it is 3 into I minus 2 into I1 minus I2. Let us call this is equation number 4. So already 4 we know, or we can consider this is equation number 5. So this is 4 and this is 5. Now let us put calculated values, that is I1. So this is the I1 value we can put here. And after putting I1 value, So then you will get another equation. So what I1 which is equal to, let us put here, therefore from equation 4, so that is 3 by 2 into I2, and I is again, so this is I, so this also we can put, already we put here same equation. So let us write this equation as it is in the next term, next page. So therefore 1 which is equal to 3I. So or we can write this equation as like this form also, left hand side. So this we will sit write in the left hand side, and this term we can write in the right hand side. 3I minus 2I1 minus I2. Let us call this equation number 5. So now put the value of I, that is 4I1 minus I2 divided by 2, and value of I1, that is 3 by 2 into I2. Let us put those values in equation number 5. Now equation 5 becomes, after putting known values, that is 3 into 4I1 minus I2 divided by 2. So this is 3 into I, that is I value, that is 4I1 minus I2 divided by 2 minus twice I1. So I1 which is equal to 3 by 2 into I2. So minus I2 which is equal to 1. So after putting known values, we will get this. Now this 2 and this 2 get cancelled. So and this 2 we are dividing. So this is 3 by 2. Let us multiply this inside. So this is 3 and this is 2. And this is 3, 6 into I1 minus this 3 will be as it is. This is 3 by 2. So 2 is there again. 2 into I2 minus 3 into I2 minus I2 which is equal to 1. So therefore this is 6 I1, this is I2, so minus get adding, so therefore this is 6 into I1. So then this is the minus. So all three terms, there is a common term, that is I2, and sign, that is minus. Or we can consider, we will add first these two terms and then we will add those terms with third one. So this term we will write as it is, 3 by 2 I2. So minus plus, that is minus 4 I2 which is equal to 1. So therefore let us write as it is, 6 into I1. So then this is the minus. We will take minus as it is common. Minus sign we will take common. This is 3 by 2 plus 4, because minus we are taking outside. This is 4 and I2 we will take common. So therefore this is 6 I1 minus, so this is 3 plus 8. 3 plus 8, that is 11 by 2. So this is 11 by 2, 11 by 2 into I2 which is equal to 1. So let us put the value of I1 which is equal to 3 by 2 into I2. 3 by 2 into I2. So I1 value, that is 3 by 2 into I1. 3 by 2 into I2. So therefore 6 into 3 by 2 into I2. This is the I1 value we got in equation number 4. So therefore this is 11 by 2 as it is, which is equal to 1. Now 2 1 1, 2 3s are 6. It's 3 into 3, that is 9. 9 I2 minus 11 by 2 I2 which is equal to 1. Now here I2 we can take common. This is 9 minus 11 by 2. into I2, which is equal to 1. So this is 9 2s are 18, 18 minus 11, that is 7, 11. 18 minus 11, that is 7 by 2 into I, which is equal to 1. So therefore I, which is equal to 2 by 7. This is the current 2 by 7 ampere. So this is I2. This is I2. So this is the one part we got. We want equivalent resistance. So this is the current I2. Similarly, we want I1. So we can easily find I1, which is equal to 3 by 2 into I2. So therefore this is 3 by 2 into I2, that is 2 by 7. So 2 to get cancelled, therefore this is 3 by 7 ampere. This is I1. So now total current. So from equation number 2. So that will be 4 into I1, that is 4 into 3 by 7, 4I1 minus I2. So I2 again is 2 by 7 divided by 2. So from equation 2, so we use only I1. So this is I1 minus I2. 4I1 minus I2 divided by 2. So after simplifying this, so 4 3s are 12 divided by 7, 2 by 7, so 7 will be denominator, then this is 4, 7 2s are 14. So therefore we can write this as 12 minus 2 divided by 7 2s are 14. So simply we can write this 10 by 14 by using table of 2. 2 5s are 10 and 2 7s are 14. Therefore I, which is equal to 5 by 7 ampere. This is the current I. This is I2. This is I1. This is I. So therefore equivalent resistance are between this arm, equivalent resistance, that is R equivalent is equal to V divided by I. So here V, that is potential drop, we consider that is 10, and current, which is 5 by 7, then this 7 will go up. 10 into 7 by 5, this is equal to 70 by 5. So we can divide this. So 5 1 1, then 2 is remaining, 5 4s are 20. Therefore this is 40 ohm. Therefore R, which is equal to 40 ohm. So we can use this space for answer. Answer R, which is equal to equivalent resistance, that is R equivalent, which is equal to 14 ohm. So now let us start the next question, that is question number 20. A voltmeter has a resistance of 10 ohm. What will be its reading when it is connected across a cell of 2 volt and internal resistance 20 ohm? So this is our last question. So let us write the given things. A voltmeter has a resistance, that is R given. So first write given things. R, which is equal to 100 ohm. What will be the reading when it's connected to the EMF? EMF is equal to 2 volt and internal resistance 20 ohm. So then what will be its reading? Means what will be the voltage of voltmeter? What will be the reading showing by the voltmeter? So V we have to find. So therefore, by using formula V, which is equal to IR, so by using formula V is equal to I into R, or V is equal to IR, I which is equal to E divided by capital R plus small r into R. So therefore, let us put the known values, given values, E which is equal to 2, R which is equal to 100 plus small r which is equal to 20 into capital R, that is 100. So therefore, let us simplify this. 2 divided by 120 into 100. So then this will be 200 divided by 120. So this 2 and this 0 get cancelled. 2 6s are 12 and 2 10s are 20. Again we can further divide. 2 3s are 6, 2 5s are 10. Therefore this is 5 by 3. So therefore voltage which is equal to 5 by 3. So further we can divide. 3 1 1, 3 1 1. Again 2 is remaining. So then 20. So then this will be 2 6 are 18. Again 2 is remaining. 2 6 are 18. So 6 6. Or we can simply write 1.67. This is volt. This is the reading showing by the voltmeter. And here all our examples from question number 10 to 20 are solved. Now all these numericals are completed of this lesson, that is lesson number 9, current electricity. Now next period we will discuss, or next video we will discuss the next examples. So keep watching our video. Thanks for watching this video. Please like, share and subscribe the channel.